Let's talk about variables and environments in R. A variable holds any value or data you assign to it. Instead of hard coding specific values into your script, using variables allows the script to handle different data without needing modification. In many other programming languages, a variable and its data type has to be declared first before assigning it values. In R, you don't need to declare a variable before use. There are two symbols that you can use to assign value to a variable: the equal sign or the less than symbol followed by a hyphen. Which one you use depends on your preference. In this code chunk, I'm assigning the numeric value 5 to A and 2 to B. C is assigned the value of A times B. After running this chunk of code, when you call C, R shows that C is 10. It's also possible to perform operations on a variable and assign the new value back to itself. We assigned 5 to A above. In this equation, R will evaluate the part on the right first. In this case, it's 5 plus 1. And then assign 6 back to A, updating A's value. But if A hasn't been previously defined, this operation will generate an error. Now you don't have to name your variables A, B, and C. Names can be longer, but there are rules. Names can be composed of letters, numbers, dots, and underscores, and no other characters. A name can only start with a letter or a dot, but variable names that start with a dot can serve other purposes, like indicating hidden variables, so it's best to just start with a letter. Variable names are case sensitive. Names that have the same spelling but different capitalized letters will make different variables. It's best practice to avoid using function names or reserved names to name variables. As an example, library is a function we use to attach packages. Right now, if you call the function without the parentheses, R will show you the function's code. Now, if I also name a variable library, library without the parentheses will call the variable. Although library with the parentheses still calls the function and it's usable, it's definitely not best practice. Another example is actually a mistake I made when I was still new to R. T is an alias for true, which is a logical value. I made a mistake of naming a variable t, thinking it was a great name for a time variable. But this line of code assumes t still means true. If whatever inside the parentheses is true, print on screen it's true. Else, if it's false, print it's false. See, t is false now. Finally, it's best practice to use informative names. It's hard to tell what A, B, or my var is when your script becomes complicated. Another important concept is environments. Environments store defined variables and functions. The global environment is your workspace and stores the variables and functions you defined in the current R session. Look here, this is the global environment and all the variables we defined today. This means that a variable might not be holding the value you think it holds. Let's say we give A the value 100. If we forgot about it and we go back to an earlier section of the script and run a chunk involving A, we would think A is 5 because the code before it says so, but A is actually 100. Therefore, it's best to clear the global environment and run everything from the top. You can also use functions to clear the workspace. The list function lists all defined objects. The remove function removes an object. Just put the name of the variable or function inside the parentheses. To remove everything from the global environment, put list equals the list function inside the parentheses of the remove function. There are different environments and they follow a hierarchy. Higher than the global environment is the environment of the attached packages, also called the namespace. When you call a function or variable and R can't find it in the global environment, R goes up the hierarchy of environments to look for it, starting with the namespace of the most recently attached package. There is also the local environment of a function. The local environment exists while the function is running. This means that variables and functions defined within a function typically cannot be called from outside the function. The environment where the function is defined is higher on the hierarchy than this function's local environment. It's important to be aware of the hierarchy of environments to make sure you're calling the intended variables and functions.